And we're starting to have the technology to be able to show such interstellar clouds in other galaxies. And they're all showing the same building blocks. In other words, the nuclear basis of DNA and RNA. And I put rather a big bet on our finding extraterrestrial biological life within the next few years, if not even actually being open with contact. So isn't that wonderful that that emergent that, as you say, that metaphysical wisdom teaching of that initiating sound of creation, we're now discovering it in the earliest epoch of our universe. I would suggest offering us authentic hope for the future, that we do wake up to remember who we really are and who we can evolve to become.
Welcome to the Quantum Theory Podcast.
Welcome, everyone, to this episode of the Quantum Theory Podcast. We are joined by returning champion, Dr. Jude Currivan, who we had earlier on. And today we're going to be covering something fascinating, which is the story of Gaia and the emergence of complexity, life, and even consciousness. And going to be covering a lot of things in her book, which is the story of Gaia, predictably, which I highly recommend everyone goes and reads and checks out following this episode to get the full breakdown. But before we hop into all of these fascinating topics, I'd like to just firstly thank you again, Jude, for coming on the show.
Oh, it's great to be here, Jared. I remember last time we could have continued speaking for so long. So we decided that probably part 2 would be a good idea. So I'm just delighted. So thank you for inviting me back.
Certainly. So what's new in the UK?
Oh my goodness, what's not new in the UK? Actually, interestingly enough, I've just come back from Iceland.
Oh, wow.
And I was there for essentially 2 forums. One was the Spirit of Humanity Forum, and the other was the Wellbeing Economy Alliance Forum. And for the first time, the gatherings overlapped, but there was a combined mission. There was a combined session with both of them. So I was invited to speak there on the stage with the incoming president of Iceland, an amazing lady called Halla Tómasdóttir, and we spoke about love being foundational. So how wonderful is that a president of a country will speak in that way? And there's so much, I think, that's going to be unfolding and flowing from that. But it was just so remarkable to hear Hattler's story of being in business and, very much in the world and of the world now as a president of a country, and really wanting that country to be a beacon of light, a beacon of love. So it was remarkable. And so much, I think, could come from that.
Wow. We need many more world leaders just like that, and many more individuals such as yourself as a proponent of that foundation of love that is certainly absent in our world today in many ways. So thank you for the work that you do. And without further ado, we're going to hop into things here, and certainly won't be able to cover 13.7 billion years in 1 hour. So we're going to try to just hit some key points here of how new findings in science are crafting a new story of how life and consciousness emerge in the universe and our planet. So taking it from the top here, the Big Bang. So you reframe it as the Big Breath. Now, what would you say is maybe incorrect in your eyes about the typical notion of the Big Bang, and how would you reframe it in your perspective?
Mm-hmm. Well, as a cosmologist, and I would say an evolutionary cosmologist, I don't disagree at all with the premise that 13.8 billion years ago, our universe began in its tiniest state. That was the beginning of our universe, the beginning of space and time and the energy matter playing out through this universal journey. The difference I would suggest between what we know of the Big Bang, we know it wasn't big, of course, because of that, it was minute, is the implicit chaos of the bang part of that. Because we now know that beginning, and from that beginning, was so extraordinarily fine-tuned, probably more than a trillion times to one variance on any of the key universal constants, and we would not be here having this conversation. So incredibly fine-tuned and ordered. incredibly ordered as well, amazingly ordered. Its lowest state of entropy. And we can talk more about that. We talked a little about that last time. So rather than a bang, I'm describing it as the first moment of an ongoing big breath. And as time has flowed forward ever since, as space has expanded ever since, I think it's more, we can sort of sense that with our own breaths as we breathe out. You know, our universe is essentially taking its out breath. And this beautifully correlates with ancient wisdom as well. The ancient Vedic tradition of India talks about our universe being the breath, the great breath of the creator, of Brahman. So there's a lot of tie-ins that I think help us to sort of share this emergent story in ways that are actually very intimate, not just so vast, but intimate to us, because that big breath is breathing through our little breaths in every moment.
Absolutely. And I'd love to dive a little bit further into that exact concept, which is going against the notion of this inherent randomness of the universe. And I think that's really the chasm. I would love to just get a little more detail. Obviously, we don't have the time to go into, particle physics and things like that, but just how even like hydrogen emerged and the perfection of sort of the initial elementary particles and the perfection of that process. If you don't mind just giving a little insight into that.
Be delighted to, because this is something that we see time and again throughout the whole story of that 13.8 billion journey. That there was a sort of almost a purposeful, almost like a pre-planning, a predisposition, time and time and time again, that enabled that ongoing journey from simplicity to complexity to take its evolutionary arc until now and beyond. So, first of all, the laws of physics themselves are innately relational, and at their most foundational are very simple. E equals mc squared, E equals h nu. You know, the relationships, and people feel that quantum physics is very difficult and challenging. I think only if it's looked at from a materialistic lens. If it's actually viewed from a deeper sense of mind and consciousness, rather than being something we have and an epiphenomenon of that evolutionary arc, are actually foundational. They're what we and the whole world are. Then quantum physics can be seen as being the simplest actually, and most effective way of existential journey from simplicity to complexity, of the way in which energy and matter relates to itself through the whole story of our universe. But going to your point and going back to the very beginning, from the very, very earliest few moments of space and time, the initial simplest two elements, hydrogen and helium, had been formed in a relationship, a mix, as it were, of 75% hydrogen to 25% helium, and little tads of beryllium and thorium, but not that would make a major or even major significant difference to the story that goes on from there. But because of that primordial mix, for the next couple of 100 million years until the first stars were formed, helium just hung around, because one of the attributes of hydrogen is it'll be friends with everybody. The point about helium is it's very picky about who it connects with. So it's neutral. But you need both of them, because when those first stars were formed, and in their centers, and the heat and the pressure of their centers that were guided into their formation through primordial magnetic and electric fields, a process starts to happen whereby hydrogen is synthesized into helium, and then from helium into more complex elements, into carbon and oxygen and nitrogen and onwards. But there is a very, very tricky equation. There's a very tricky process that happens between helium and carbon, and it's called a triple alpha reaction. And that's where three helium nuclei come together to form a nucleus of carbon. But it's incredibly resonant. It only takes place, it happens so quickly and is required to be so resonant that it only actually succeeds something like 1 in 2,500 attempts, as it were. Now, the point is, if the presence of helium was very small in that stellar mix, then the chances are there wouldn't have been enough helium present to ensure that that triple alpha reaction happens sufficiently often to cross that threshold into carbon. So the stars needed that primordial helium hanging around for millions and hundreds of millions of years to make sure there was enough in the mix to enable that next stage of nucleosynthesis to take place. If that hadn't been the case, we wouldn't be here, because we're biological organisms. You know, our foundational structure is carbon-based, and the rest of our structure is heavily dependent on oxygen and nitrogen and a couple of other even more complex elements. And biological organisms require something like 61 elements of the 94 naturally created in the universe. But that key threshold was foundational to any further complexity. That's just one example. And we find time and time and time again that sort of pre-planning, as it were, was crucial to what came after and what was able to come after in that journey to greater complexity.
And I feel that there's just so many of those pit stops where if this didn't happen perfectly, we wouldn't be here. If this didn't happen perfectly, we wouldn't be here. And even throughout reading your book, I mean, just the amount of those instances of absolute precision. I mean, we're talking about billions and billions of years ago. If there wasn't a certain composition between hydrogen and helium to allow star formation, there wouldn't even end up being carbon and organic life eventually. And that's just one thing billions of years ago. I mean, the improbability of the sequence of events that would have to have happened for this moment right now to be happening is mind-blowing. And it only can lead you to see the design behind these things. And I would love just to touch on one little point on an esoteric note from your book about the ohm and that how the universe initially was actually opaque to visible light, but was sound could traverse the universe. And so there was this initial vibration that allowed for the actual seeding of these stars. Do you mind touching on that a little bit?
I'd be delighted to, because it's such a beautiful story. And again, it correlates with ancient wisdom. As you said, Jared, the universe began in its simplest state, its most ordered state, its tiniest state, and its hottest state. The Planck scale temperature with which our universe began was something like 10 to the 32 degrees Kelvin. When you I know, that's warm. That is warm. And and there's a reason for that, because the laws of thermodynamics actually play out. The third law of thermodynamics is that the temperature of a container system is inversely proportional to its informational content, what I describe of as entropy, which is expanded beyond the thermodynamics of the energetic states of entropy. So our universe began in its highest temperature, its lowest entropy. And ever since then, as time has flowed and space has expanded, the temperature's reduced, but that's enabled the informational content, the entropy of our universe to increase. That's the story of evolution in a nutshell. But just going back to that temperature, the temperature was so hot that space, indeed, as you say, was opaque to light. It was only able to undergo what's called its recombination era about 380,000 years after the beginning of our universe, when it had cooled down to be transparent. But in that earlier epoch, when it was opaque to light, as you quite rightly say, it was not to sound. And so the best modelling we have currently is that sound waves were pulsing through that early universe, starting themselves to shepherd the emergent material into what will become stars much, much later. But the point of that modelling shows that it wasn't just a single note. It seems the best modelling we have suggests a chord of 3 notes. And of course, when we go back to ancient wisdom, an Om is comprised of 3 notes. So
Wow.
isn't that wonderful that that emergent Om, that, as you say, that metaphysical wisdom teaching of that initiating sound of creation, we're now discovering it in the earliest epoch of our universe.
Wow. That is just unbelievable. And on a little bit of a side note, how do you think that those people that long ago figured that out? Just curious your perspective on that. If you have any thoughts there.
We probably have another session to play out on that one. I feel it's twofold. First of all, the rishis, which were the sages of ancient India, as indeed many other sages and mystics throughout time, have been able to tap into our innate ability to be the non-local consciousness, microcosmic co-creative consciousness of our universe. So by being able to do that, just as we now are really appreciating that we have supernormal attributes. You know, there's so much unfolding now in terms of telepathic communications, precognitive understanding, near-death experiences, you know, that's really showing us what I mentioned earlier, that mind and consciousness aren't something we have. They're literally what we in the whole world are. And if you are in a tradition where as a person perhaps especially sensitive to that ability to connect into, then you can gain those sort of insights that, whether we call them intuitive or just being able to be at one with the universal sentience of which we're all a part. I feel that gave insights, and many scientists, myself included, get a lot of our insights through those sort of those deep realizations. Einstein talks about it, Max Planck talks about it, many other scientists have had such experiences that have offered them these aha moments of realization. So that would be my quick response to how could they know? Because they knew, and we too have a knowingness if we're willing to open ourselves to its wisdom.
Mm-hmm. I think that's beautiful. And I think we are living in a time where it might be able to sneak into the rational brain, because now we have the science and the quantum physics and the experiments and the telescopes. And, you know, so I think we're living in a very exciting time where the two might be bridging for the masses, which is, of course, the goal of this platform here. But to make sure we use the best use of your time here, I'm going to get back to the main track. And so resuming our story. So these stars have blown up. So they've run out of their fuel. And so now we have, even elements like carbon that have been, through nuclear fusion, heavier and heavier elements are being formed in these stars, which are basically the sort of the cradles of elementary particles of the universe. And so now we have sort of these interstellar dust clouds forming. And with the help of these perfectly ordered magnetic fields as well that, help them coalesce. And so one of the things that I think is an extremely interesting topic nowadays, and that you touched on, is that you've suggested there's actual really strong evidence that some of these interstellar dust clouds actually contain the building blocks of macromolecules like DNA, RNA, like nucleotides, proteins, lipids. So this could suggest that life is a universal phenomena as opposed to something that's random and just pops out of Earth, otherwise known as panspermia, I believe in jargon sense. So do you mind shedding some light for the audience on how can we build our intuition around this, and what kind of evidence is out there now for this?
Very, very, really direct experimental evidence, and that's why I feel it's so helpful. Just want to take a little step aside, because what we're also realizing that in the very early universe, galaxies were forming very early. And the reason it seems that they were forming very early is that the very massive stars that were then the norm, space was much smaller, those early generations of stars, those first and second generational stars, were huge, and some of them indeed became supernova at the end of their day. They blew up, and that's how they started to see the interstellar clouds. But galaxies themselves really are enabled by many of those massive first stars to actually, at the end of their life, rather than explode, become black holes, to collapse under their gravitational weight, become black holes, and then coalesce into supermassive black holes, which form the sort of the center, as it were, the gravitational center and stability for galaxies to then form around them. So that was absolutely needed in order then for interstellar clouds of stardust and ice, water ice, to be able to form after several generations of stars that then were able to be the birthing clouds for planetary systems. So going back to your specific points, yes, indeed, what we found in the last few years is the spectroscopic evidence that such clouds, and we've got some amazingly beautiful images, firstly from the Hubble telescope and now from the James Watt telescope, the JWST, of these interstellar clouds. And you can see that they're denser, they're warmer than the surrounding space, and they are replete with the building blocks of prebiotic organic molecules. And that goes to the building blocks, amino acids, it goes to the building blocks of lipids and sugars. And until recently, we also, simulations suggested they should also include the nucleobases of DNA and RNA. And in January of this year, 2025, after a robotic probe, which you'll like because it was called OSIRIS-REx, went to an asteroid. I thought you'd like that. Went to an asteroid called Bennu, which is probably at least 4.6 billion years old. So really left over from the early formation of our solar system. And got a little bit of material, which then it was able to bring back to Earth and be analysed. And that analysis has indeed shown that in addition to numerous amino acids, which are the building blocks of proteins, all 5 nucleobases of DNA and RNA were present. And so this is before the planets of our solar system were born. So going back to your point around panspermia, which was indeed the name given to the idea that the origins of biological life on Earth were effectively gifted from before Earth was formed, is getting more and more and more evidence, both the organics and the water. And we know that all biological organisms of any complexity require planets with liquid water. So we've now got this evidence from out there in interstellar clouds. Now, the point is, therefore, those interstellar clouds are birthing solar systems across our galaxy. And we're starting to have the technology to be able to show such interstellar clouds in other galaxies. And they're all showing the same building blocks. In other words, the nucleobases of DNA and RNA seem to be common. Because we also know that when we simulate the appropriateness, the efficiency of DNA as a molecule, it is the best it's a 1 in a million best structure to hold memory and to have also the flexibility and resilience to support the greatest level of biological emergence and complexity.
Wow. I mean, that's unbelievable. I mean, especially how recent this evidence is. I mean, even as late as 2025. Yeah. I mean, the implications of that are infinite. And I would love just to get a little bit of a personal insight on your side of things. What do you think about life given this in far, far, far away galaxies? Even in our galaxy, what's your hunch on that?
I think it's more than a hunch. I would be astonished. I'm not a betting person, but if I was a betting person, I'd put rather a big bet on our finding extraterrestrial biological life within the next few years, if not even actually being open with contact, because alongside this, it's almost like it's again going back to predisposing us or predisposing the universe to greater complexity. It's almost as though these discoveries of the universe tapping us on the shoulder to say, you're not alone. How could you be alone when
Right.
all of this was there before, our solar system was formed? That we're finding there's more planets and stars in our galaxy alone. We're seeing this commonality of prebiotic emergence that is the same throughout our galaxy and therefore likely beyond. We're already sending probes to the moons of Jupiter and Saturn. We're already
Oh,
now
wow.
at an advanced stage where it's, the evidence is strong that Mars was originally a water planet and that early microbial life could have evolved there. The same goes for Venus, quite likely. And we, of course, as Gaia, we're in the perfect position of what's known as the Goldilocks zone. So we, of the three, were the best suited to be able to nurture. Our planetary home Gaia was the best suited to be able to nurture complex life. But I think it's everywhere. We're going to be finding it everywhere now. The question is, to what degree of complexity? But I would also say that we're finding so many Earth-like systems. Gaia is very special. Our system is very special, but there's still likely to be hundreds of thousands, if not millions, of such systems throughout our galaxy alone. So the chances of us not finding or not being discovered by or not contacting or being contacted by other extraterrestrial beings, I think the chance of that not happening are vanishingly small.
Mm. And what do you feel that these commonalities, these sort of codes of the universe's processes are encoded on our holographic boundary and manifested as meaningful information that is kind of the guiding force and rails of this emergence across the board, across the whole universe? Or do you think there's kind of basic rule sets in a complex system and everything else is sort of an emergent property that's not necessarily... I guess the question I'm trying to ask is, do you think this comes from just simple rules and the universe is kind of guiding novelty? Or do you think these are all sort of already encoded in sort of that informational space? Does that make sense?
It does. I think it's a sort of both and. Because when we go back to the origin of our universe, the laws of physics are those relational those relationships between energy and matter and space-time. Because of the holographic principle, this is pointing us to the appearance of our universe of energy, matter and space-time emerging from deeper realms, non-physical realms of informational, meaningfully informed causation, and therefore essentially a sentient universe that meaningfully exists, and I would suggest to purposefully evolve. So from that very first moment, the universe is existentially able not just to meaningfully exist, but also to evolve from simplicity to complexity. So there is an emergence, and that emergence, is enabled by the flow of time from that first moment and the expansion of space from that first moment, with ever more information being able to therefore be manifested through this journey of simplicity to complexity. So that, it's not a deterministic journey that necessarily had us as humans coming out 13.8 billion years later, but I would suggest it has sentient, individuated, self-aware, biological beings coming through that 13.8 billion year journey, of which we are one.
Mm. Well, speaking of that 13.8 billion year journey, I'd like to segue now to the idea of our solar system and continuing this theme of improbable sequence of events that continued to happen that led to us eventually. And a couple of the things that I found unbelievably fascinating in regards to now kind of zooming in on our solar system would be the grand track hypothesis, where we kind of have Jupiter and Saturn coming in towards the sun and hanging out for a little bit and getting the inner planets to their final perfect masses and, going back out. And that needed to happen. And even more fascinating, in my opinion, the Theia hypothesis, that there was a massive collision with Earth, which then created the moon, which was critical for our future seeding of organic life here through various different ways. I'd love just to kind of, if you could touch on those kind of couple main ideas.
Yeah, I'd be delighted to. I mean, first of all, with the best understanding we have at the moment, and this is a work in progress, very much so. And I think over the next few years, some ideas may be thrown out or refined and others will come in. But this is the best understanding we probably have at the moment, is that first of all, our planetary system emerged from one of those interstellar molecular clouds thanks to the supernova explosion of a star probably about 200 million light years away. So if it had been much closer, it would have been in what's called the kill zone. And so the molecular cloud would have been sort of chaotically dispersed or whatever. If it was too far away, its shock waves wouldn't have been strong enough to really shock the cloud into a collapse. But it did. And that collapse itself was not chaotic. So the molecular cloud collapsed into a protostar at its center, and then a planetary disk called a proplid around it. And in that proplid, that disk really formed all the planets of our solar system. And the orbits themselves were harmonically resonant. Yeah. So they themselves were ordered, and rather like a sort of string of beads or a symphony, a beautiful sort of symphony of creativity. But there's certain aspects, especially of our outer solar system, that don't sort of work just from that being a stable dynamic. There were other things that needed to happen if the planets where they currently are were able to get where they currently are, rather than where they likely originally formed. One of those is the great tack, which is the idea that Jupiter and Saturn had gone more inward to the inner solar system, but then the resonance between them had sort of slingballed them out again to their current orbits. And I write about that in the book, and there's quite a lot of science and pinball wizardry around all of that. But the other one that you referred to was this idea that it looks like Gaia, when she originally formed, our planetary home when she originally formed, was smaller than she is now, and there was no moon associated with her. But in the very early days of our solar system, that a body probably the size of Mars, this is our best understanding at the moment, a body about the size of Mars, and likely coming from the outer reaches of our solar system, came in and collided with Gaia, but in a way that didn't destroy her. Instead, that first of all, it looks as though the density of Theia was likely very dense, which is one of the reasons that there's the understanding we have a very dense core, an iron nickel core. We're the densest planet actually in our solar system. So the idea is that is a gift essentially of Theia. Theia came in, collided with Gaia, settled into a core because her body was denser than that she'd collided with, but then sufficient material was also thrown off that became our moon. And we've got good evidence for this. We've got certain sort of anomalous parts, blobs, as it were. They're sometimes called blobs, actually. They're called other more sciencey terms, but blobs is the nickname. One under Africa, one under the Pacific, that may be remnants of Theia. We may also see part of her actually in beneath the mantle and in the core of Gaia, and that's crucial, because we need that heavy metal core for our magnetic field, and our magnetic field is crucial to protecting us from the solar wind and ultraviolet and all the rest of it. So that is vital. But also, as you mentioned, our moon is huge in relationship to Gaia, larger than any other moon to planet relationship in our solar system other than Pluto's moon, Charon. But our moon is crucial, and she has been throughout the whole story, because back when Gaia was born and Theia came in and our moon was formed, our sun was much dimmer, much less radiant than now. And at the distance from our sun, and with the amount of water that had been provided to Gaia by that point, we would have probably become a snowball planet. But our moon and the tides, because she was much closer to us at that point, the tides that she was raising kept us sufficiently warm. She was like a mother nurturing a child, and gradually, as the dynamics meant that she shifted far away, that correlated with our sun gaining in radiant strength. So again, it's a beautiful trinity of sun and moon and Gaia, but Theia is like our planetary grandmother. And, lunar rocks that have been brought back from Apollo landings in the past suggest that the deeper that we look into lunar, the more we find evidence of Theia and the commonality. And Lunar's rocks and Gaia's rocks are very similar. So we know that they came from an originating body, but we also have evidence, deep within Gaia, and also, I think, progressively within Luna, that Theia was crucial to that formation.
Absolutely fascinating. Now, because of the improbability, of all of those different things happening, which perfectly allowed for our magnetic field, allowed for, tectonic plates, allowed for us to even survive when the sun was cooler, or not us, but, Gaia, are those things prerequisites to allow for eventual emergence by having that good of a magnetic field and things of that accord? Can those sort of sequence of events that we had, like with Theia and so on and so forth, do you believe that it's possible to not have those things happen and still be able to see this type of emergence?
It depends on the level of complexity we're talking about, because, I think life will find a way, and by life I mean a living universe, but a living universe whose journey has moved from simplicity to ever greater complexity, and then to the complexity probably about 5 billion, 6 billion years ago, across galaxies, of the ability to have planetary systems that were able then to harbour the further emergence of biological life and biological complexity. The question is to what degree of that complexity? Because, for example, I mentioned that probably Mars and Gaia and Venus were all water planets to begin with. But Mars is further away from Sol than we are. So on the outer reaches of what's called the Goldilocks zone, which is where liquid water can easily, not easily, but can exist. Also, Mars is much smaller than us. So the gravitational field of Mars is about 67% of Gaia's. Now that means that the atmosphere is less dense, it's less, and the gravity is less dense, more difficult to hold on to that water, and also colder. So less propitious, less nurturing in terms of biological emergence, but the likelihood is, I think we will find it, that microorganisms did develop on Mars and may still exist beneath the surface. We're still, the general view is that water is still likely. Well, it is, because we know the poles, but we'll find quite a lot of water beneath the surface, and the likelihood of microorganisms. Similarly, on some of the moons of Jupiter and Saturn, even on Charon, the moon of Pluto, beneath the icy surfaces, there's looking the possibility of liquid oceans and sufficient heat from the radioactive cores and the tidal movements of those moons that, again, organic life could have emerged there to some degree. We don't know yet. But on Gaia, it was like the perfect mother planet. as you said, Jared, with Theia coming in and heavy and high in metals, we have probably the largest magnetic field of any planet in our solar family, with the densest, so our size is perfect for the emergence of biological complexity and beings, biological organisms from the tiniest to, the blue whale and the dinosaurs. So a vast array of abundance and diversity and complexity. The benefit of tectonic plates and the whole subduction process through Gaia's geosphere means that she has, and also what's called the Milankovitch cycles, which is due to her elliptical orbit and her axial angle and her wobble. We have over long periods of time this incredible abundance of diverse environmental niches that of themselves are conducive to that ongoing emergence of evolutionary complexity. So everything, our temperature, our magnetic field, our size, enables the information, the universal information that is foundational to our entire universe, to have a planetary home whose gravitational gradient is vital to guiding the bodily morphologies of biological emergence through time and in space. In other words, our bodies require us to be children of Gaia.
So that's actually a question I had as well. So in terms of morphology, so do you believe that there's some type of, quantum field that's sort of informationally guiding our three-dimensional structure, or is it related, as you said, to the gravitational aspect? How would you frame that? And to kind of extend upon that, that's actually a perfect segue, because I kind of wanted to hear generally just, your bone to pick with Neo-Darwinism and, what, and because I agree, but I'd love just for the audience to kind of hear, just again, continuing this chasm, where sort of that perspective of it was, mutations, that's it. And I think mutations is kind of like a shut up and calculate. It's like, don't worry about it. It just happened. Here we are. Here's consciousness. Here's this perfectly ordered Gaia sphere and, everything like that. And I almost think that, in my opinion, that the word mutation is like a god of the gaps of Neo-Darwinism. It's like the most important thing that's inexplicable. And it's just a random mutation, which you explained so well, how DNA is literally designed to be error corrective and have the like 1 in 10 billion or 10 million copies has an error because through the process of going to RNA and how RNA helps correct for that. So, I mean, obviously there's so many things I want to talk about here, but to try to synthesize all of that down. So what would you say is the general divide between that neo-Darwinist type of perspective of just mutation versus an information theoretic complexity type of perspective that you put forth?
Okay. Well, first of all, as you know, both in the Cosmic Hologram and the Story of Gaia, I share tens of thousands of peer-reviewed papers and scientific findings across all scales of existence and many fields of research to support this informational perspective. The meaningful, vitally meaningful information is essentially underpins the manifested appearance of our universe. And at all scales and in its entirety. And our universe exists and evolves meaningfully and purposefully within that unitive, non-local entirety. So that's the sort of grounding. And then, yes, because Neo-Darwinism is an extension not of Darwin's initial views, but what they became perceived by the mechanistic science of the 19th century. And the mechanistic science of the 19th century, its technologies drove the Industrial Revolution. So it became the foundational mindset for all that's gone on since then in terms of hierarchical governance, organizations, education, systems of all sorts, exploitation, separation. It's a mindset of materialism and separation. But the point is, Jared, that it's 120 years out of date.
Right.
And the other point is that Darwin was a superb scientist. He followed the evidence wherever it led, and he realized that the evidence that he in his life was able to come to only took it so far. And therefore, he knew that evolution was a way in which biological organisms changed over time. And they changed because they responded to their environments. And that's what he meant by survival of the fittest. He didn't mean the most competitive. He meant those that fit their environments the best. They were the ones that survived and thrived and therefore went into future generations, because that was the evidence he had, and it still applies. The point is that when genes were discovered and genetics became a scientist, that was the foundation for what's known as Neo-Darwinism. But that mechanistic mindset that Darwin himself did not share, that mechanistic and materialist mindset that he did not share, but almost hung on to his name because of the social implications of evolution. And by then he wasn't, he'd passed over. He wasn't able to sort of do anything about that. But that then became the mechanistic, materialist, separatist mindset that fed into Neo-Darwinism, with genetics founded on that same perspective and therefore based on randomness, without any meaning, without any evolutionary flow and purpose and guidance. And the evidence that I laid out in the Story of Gaia completely turns that on its head. Because what it shows, as you say, is so many reasons, but that DNA, as I mentioned earlier, 1 in a million effectiveness in being able to memorialize a biological template, but not passive, proactively dynamic and able to be responsive to environmental signals. In a dialogue, a multi-way dialogue, DNA, RNA, an organism's itself, its ecosystem, the entirety of what I call the Gaia sphere, takes part in this ongoing informational dialogue. So yes, when a signal comes in and the signal through RNA goes to the DNA, unzip the DNA, takes out the requisite information, something like 1 in 10,000 or so times that happens as an error. That error is ruthlessly cut out by the ongoing RNA processes, so that by the time that the site whereby amino acids form to form proteins that build the body, it's down to an error rate of 1 in something like 10 billion or even less. It's ruthless because random mutations are not beneficial to the organism. They are destructive. They end in sterility or mutations that are detrimental to the organism. So they are ruthlessly cut out to retain the integrity of the organism going forward. But this is where it gets really interesting, I think. Evolution, biological evolution, tends to have 3 pulses. The very slow, which is when the environment is stable, which it has been with us since the last ice age, essentially. Therefore, there's been very little change in genetics. There's been some, of course, with environmental adaptation, which is what Darwin saw, but no great leaps in speciation. There's a middle rate pulse, which is due to what I mentioned earlier, the Milankovitch cycles, which is due to Gaia's elliptical orbit, closer to, further away from the sun at different seasons, due to her axial tilt, due to her wobble, and the tectonic plates and all the rest of it, environmental niches, they tend to give rise to medium scale speciation and change over time, but reasonably long periods of time. And then you get the incredibly fast evolutionary processes, when often caused by catastrophic change. So we've had 5 major, possibly 6, possibly more sub-catastrophic changes to the overall Gaian environment over the last 4 billion years or so. And each of those have driven rapid and radical evolutionary mechanisms. And that's driven by what's called horizontal gene transfer. And crucial to horizontal gene transfer is is viruses and bacteria who are promiscuous with they don't care who they change DNA with. They don't care at all. They'll change DNA with anybody. And that's why with horizontal gene transfer, we now are beginning to really understand the level of radical change and the speed in which it can change through these processes, but they're all underpinned and pervaded by the flows and processes of meaningful information.
Man, I think one thing I'd love to follow that up with, just for the audience, to give them a little window into the book as well, as an example of even one of those sort of viral processes, and just to further quadruple down on everything you're saying about this meaningful information, purpose, drive towards complexity that we're seeing. And one example from the book that I wanted to highlight that just, amongst so many, I mean, I truly cannot emphasize enough for people to really need to read this book. But one of the things is there's this slug that hatches a larva and it eats a certain algae that has a chloroplast that, of course, absorbs the light. And so they assimilate the chloroplast. I think they bring it towards like their outer layer of their skin. They get rid of their mouth because they're now a solar powered slug, and then a virus now goes in there and reverse engineers the protein making genes to create the proteins to sustain the chloroplast from the algae. So it reverse engineers the algae's genes that make those proteins and stalls it into the nucleus of the slugs. So the slugs can now make the proteins that sustain the chloroplast so they can continue being solar powered. And it's like, really random mutations, like, come on, you know what I mean? Like between the viral collaboration and like, yes, these slugs somehow have the wherewithal to know, and like these viruses that are just on the nano scale have the understanding they need to help the slugs in this way and go decode information of DNA. Like, it just has me perpetually just in awe of life, and that is just one thing out of the plenum of versions of life. So if I don't know if you want to add on top of that, I just had to get that out there.
I'm so glad you did, and I'm so glad because, like you, I feel the story of Gaia wrote me. I had the great privilege for the book to write me, and if I wasn't, and I was in awe of Gaia before the book, oh boy was I at the end of the book. I mean, just these stories. But yeah, I mean, you touched on something I think is really, really significant, not just for the slug, but generally in terms of, evolutionary emergence, biological evolutionary emergence. And that is the role of viruses. Because very early on, most biological life forms went from simplicity to complexity, single cell to multi-celled and onwards and onwards. But viruses went the other way. They simplified and simplified and simplified, such that they are only able to be active in association with a host. And yet what they have is this innate informational sentience that enables them as colonies to choose whether to kill a host or to enter a symbiotic relationship with a host. And they're the only organisms we know. And for many years, many biologists refuse to see them as life forms. They're now being understood as being evolutionary partners and agents. But, with the slug, it's the symbiotic relationship. But the point is that they're the only organisms we know that can reverse engineer DNA. That's why they can go into a cell and change the DNA. And we now know that there's a whole group of genes that are human endogenous retrofit viruses, HERVs, that actually enable embryonic development, fetal development. And so when we talk about mammals and being able to bear a child as a fetus within an amniotic sac, yeah, within a womb, an amniotic sac, that is looking more and more like that was a major viral intervention to enable that to happen. And if that hadn't happened, certainly you and I wouldn't be having this conversation in the form we take. But time and again, we're seeing that. And so viruses are crucial, vital as well in these whole sort of radical reorganizations and transformations of horizontal gene transfers that literally trigger the whole next arc of evolutionary emergence and have done throughout Gaia's story, from, simplicity to complexity.
The only thing you're left to conclude is that intelligence underlies and pervades everything. Because you think about how small a virus is, right? Because what's the scale of a virus to a cell? What do you? I remember you tracking that in the book. Or what's the scale of a virus comparatively to something
even
really?
to a bacterium, it's
So bacteria.
minute compared to a bacteria, and a bacteria is tiny, certainly compared to a nucleated cell. So
Right.
absolutely minute.
Right. And so we're talking about orders of magnitude smaller than the smallest things we can imagine. And these viruses not only cooperate with each other and sort of have a shared intelligence, but they have a knowing of how to even decode DNA. Like, think about a human being, us, how hard it is to learn something like, CRISPR and how to modify genes and what that takes. And we're talking about a virus, has that figured out at that scale. So less of a question, more of a testament. I think that's just my shared awe as you, Jude, with life and the universe's inherent intelligence. And that, I think, by the time anyone finishes your book, they can only conclude the same.
I feel so too, but that's why, Jared, thank you for that. But I really wanted to share the evidence because
Please.
it is so deep and so rich, and it's at all scales. And literally, the book is the story of Gaia. But of course, like our stories go back as far as we have a memory for, Gaia's story goes back to the very beginning of our universe. So this is a 13.8 billion year story, from that initial simplicity to ever greater levels of complexity and radical abundance, and all, absolutely all, in my view too. And the evidence, I would say, I can't, come to any other view either, is that our universe meaningfully exists to purposefully evolve, so that, its innate sentience can be embodied in individuated, self-aware beings that are able to look out to the stars, to appreciate a planetary home, to have this conversation. And it seems to me to be now in our own journey of evolutionary potential, because I'm reframing in my work now from us being in a meta-crisis, which is really, in my perspective, a dis-ease of our mindset of separation, into a potential metamorphosis, where the old may break down, it may dissolve, it will dissolve, and yet the imaginal cells of the new, the old cocoon, the old caterpillar, the human caterpillar, into a chrysalis, into a cocoon, and now with the imaginal cells of an emergent human butterfly. What an amazing time it is, with all its turbulence, with all its challenges, but also I would suggest offering us authentic hope for the future, that we do wake up to remember who we really are and who we can evolve to become.
Wow. And with those profound words, we will conclude today's conversation. But Jude, thank you so much again for your time and wisdom today. It was an absolute thrill running through a brief history of the universe and life and sentience. And everyone as well watching this, please go to Amazon and check out The Story of Gaia by Jude. You will certainly not regret it. But Jude, thank you so much again and have a fantastic rest of your weekend.
Thank you, Jared. Thank you again, and you too.
Awesome. Take care. Bye, Jude.
Bye, my dear.
Thank you for tuning in to this episode of the Quantum Theory Podcast. If you desire to embark on the path of self-mastery, visit quantumtheorypodcast.com to join a like-minded community of purpose seekers committed to personal growth.